Done. Okay. So last class we have discussed about code converters, codes and code converters, right? So last class was about different types of codes. Conversion is not done yet, right? So how many codes you have learned in last class? How many types of codes? Broad category was 5. One by one tell their name. Weighted codes. Next, self-complementary codes. Next, unit distance code. Next, alphanumeric codes. Next, slicing code. Next, error detecting and correcting code. Right. Now, today we will discuss Boolean algebra. Boolean algebra. Right. Because Boolean algebra is required to solve Boolean expressions. Right. And we are going to develop different types of logical expressions which are basically known as Boolean expressions, right? So to simplify them as well as to realize them, we have to use this algebra, Boolean algebra. So any idea about Boolean algebra? How it came, who developed it, and why we are studying? So नाम से कुछ आइडिया करो. Boolean algebra. That means George Boole developed the concept of this algebra. George Boole first developed the concept of Boolean algebra. That time it was a simple Boolean logic, but later Claude Shannon further developed it and applied the concept of this algebra to switching circuit, right? In one example of switching circuit, at the example of the switching circuit, you already studied your lab and you are performing experiments related to this subject, right? So there will be one switching circuit and its application. One switching circuit and its application. And this was happened in 1938. And George Boole developed this concept in 1854. 1854. Right? 1938. And in between this, nothing has happened. Later, after 1938, in the year 1946, first transistor came into picture. 1946 transistor, and from that time till date, transistor is considered as one of the fast switching circuit. From that date, means from the initial stage, that time it was backup type component. Now we are moving towards using semiconductor, right? That means SMB4. But till date, transistor is considered as one of the fastest switching circuit. Even when we were studying different types of logic gates, right? say AND gate, OR gate, NOT gate. The building blocks or primary element of these logic gates or the logic gate package in forms of IC are what? Are transistors. Right? That means transistors are used to develop these types of gates, which are known as logic gates. Now it is clear. Even you can find in your processors, whether it is microprocessor, whether it is microcontroller. That means any form of processor must have transistor for switching operation. Switching operation of what? Your inputs. Right? And inputs means what? Input means what? Binary inputs. So lots of combinations are there. That means it requires first test operation. Right? For example, if your clock speed is 6 gigahertz, so its equivalent bits will be what? Giga means what? पता होगा 6 gigahertz the frequency means what? It can process how many bits within a second? Giga. 6 gigahertz. That means what? In the range of billions, right? That means billions of information it can process within a second. Clear? That's why switching circuits are important, right? And fastest switching circuits are important. Not only switching circuit. Switching circuit means you can also use a dual switch for on and off, but it is not the fastest one. Fastest one is the what? Transistor. Clear? So today we will discuss about this Boolean algebra and its real application to solve or to implement any logic equation. So to understand Boolean algebra, we have to first understand the Boolean variables, Boolean constants, and Boolean functions. Right? So these three are very, very important. First one is Boolean variable, Boolean variables. Second one is Boolean constant, and third one is Boolean functions. Right? So what are Boolean variables? I already told you in your lab class. So tell me, what are Boolean variables? Last page. কি করছো তোমরা? কোনে? ডিস্টার্ব করো না। ভালো না লাগলে আসা দরকার, কিন্তু ডিস্টার্ব করবে না। What are Boolean variables? Any idea? What are Boolean variables? Boolean variable means what? The variables are used to express the equation. Right? When we are talking about inputs, inputs में क्या होता है? Inputs में 1 0 होता है या कुछ अलग फॉर्म पे उसको लिखते हैं हम A B. That means we are defining our equations variables, realizing our equations with Boolean constant. Right? As well as gates. So capital A to capital J and small a to small j, they are all Boolean variables. Clear? What are Boolean variables? Boolean variable means what? The symbols used to define the equation or to form the terms is known as Boolean variables, and their range is limited, capital A to small capital J and small a to small j. Right? Now coming to Boolean constant. So Boolean constant means what? Boolean constant means what? The Boolean variables which holds some values. That is the constant. Whatever you are writing in your truth table, basically defined by constant. Variables are there for naming purpose. Means what? For identity. But actual value is what? Constant. So what are Boolean constant? 0 and 1. So Boolean variable means capital A to capital Z or small a to small z. Boolean constant means 1 or 0. That means when you are calling your variables as events, events means what? Events means what? When you are say light is on, its opposite event is light is off. So this is an independent event, this is an independent event, right? On is a separate state, off is a separate state. Similar, true, false. This is it. Next, you can also define the events by yes or no. That means they are all events. Means the actual occurrence of your state. State means when you are writing inputs like A and B, so their occurrence is known as events. Means their conditions. Right? And in Boolean algebra or in any logic system, whether you are using positive logic or negative logic, these are same. Right? Positive logic or negative logic. So on means what? 1. Off means what? 0. True means 1. False means 0. Yes means 1. No means 0. Clear? So Boolean constant means 1 and 0. Now Boolean function. Tell me Boolean functions. AB plus AB bar. AB plus AB bar. Boolean function means what? The variables and the relation with the gates, that is defined by the function. That means suppose if you take a AND gate, its inputs are A and B and its output is Y. And Y how we are writing outputs? Y is A into B. So this Y equal to A into B is nothing but function. And Y is a function of input A and input B. And Y is dependent with A and B. Clear? So OR is a function, AND is a function. Basically their operation. NOT, XOR, XNOR, NAND, NOR. Right? So these are called as Boolean functions. Now coming to next part, that is the laws. Boolean laws. Because ultimately you have to use either single variable or multivariable Boolean laws to simplify our Boolean expressions. Right? So it is important to understand the Boolean laws. Like normal algebraic operation. Normal algebra में क्या है? इसमें भी laws है. A plus B the whole square, A minus B the whole square, like what? And we have used these laws for simplification of algebraic equations. But here we have to deal with Boolean equations or Boolean expressions. That means we have to study Boolean laws. So you can find some single variable Boolean laws, single variable Boolean laws, and some multivariable Boolean laws. Multivariable Boolean laws. Any idea what are single variable Boolean laws and what are multivariable? Any idea? দীপার পাশে লিখে বসেছিল তো দীপার পাশে বসে দীপাই তো কি বলছিস তুই তোর শুনবে হ্যাঁ দেখতে পাচ্ছিস না আমি বললাম ভুলে গেছি লিখছিস তো চেক করবো okay so single variable Boolean law there are total options is 4 5 6 7 8 single variable Boolean law 6 4 5 6 7 8 4 anyone else সবাই হচ্ছে বুদ্ধিমান পোকা জানিস না কতগুলো আছে ওকে single variable means only one variable is associated to form the law. For example, a plus 0. Number 1, a plus 0 is a. Number 2, a plus 1 is 1. Number 3, a plus a is a. Number 4, a plus a bar is 1. They are in yellow. Another number 5, a into 0 is 0. Number 6, a into 1, a. Number 7, a into a, that is a. Number 8, a into a bar, that is 0. So 4 plus 4, 8 single variable Boolean laws are there, right? And why we are calling them single variable? Because you can find only one variable at its form, and here it can be any variable from A to J to express them. Here it is not fixed. Right? You can take capital A to capital J or small a to small j, any variable to define or to express this law. Single variable Boolean law. But don't mix up. Means you are taking A and then B. That means it's two variables. But actually it is the same variable with its complementary form or any other form is present. Right? These are total 8 single variable Boolean laws. Clear? Now coming to multi-variable Boolean laws. Here you can find 3 types, mainly 3 types, and in product sense so many types are available. Product case, number 1, commutative law. Number 2, associative. And number 3, distributive law. These 3 are multi-variable Boolean laws. So first one write down commutative law. So in commutative law, write down the order of the variables. Write down under commutative law, the order of the variables in AND or OR operation does not affect the result. Right? The order of the variables in the OR and AND operation does not affect the result. Means what? Means if we can write A plus B, then it can be written like B plus A. That means what? We are basically changing the position of the variables, and after changing it will not affect the end result, or this changing is not important, right? Important is what? Important is the value. Or say A is 0, B is 1, then previously it was A plus B means 1 plus 0 plus 1, right? So ultimately is what? 1. After changing their position, B is what? 1, A is 0. end result is 1. That means it does not affect the end result. Or you can say the order of the variables in the OR and AND operation is not important. Clear? This is all about commutative law. Now coming to the associative law. Here write down the grouping of the variables in the OR and AND operation again is not important or does not change the end result. First one under commutative it was order. Now associative, grouping of variables. Grouping, right? Grouping of variables in AND or OR operation does not affect the result. It is not so important. Example, let's see under associative law. A plus B plus C. Can we write it? A plus B plus C. Does it affect any end result? No. Similarly, A into B into C can be written as A into B into C. So this is in OR operation and this is in AND operation. Right? Clear? Associative law. For verifying, you can take the values of A, B and C in this way and check it what you are getting. Now coming to the third one, that is the distributive law. Write down under distributive law. In distributive law, the term by term multiplying is just the same way as in ordinary algebra. In distributive law, write down multiplying term by term in just the same way as in ordinary algebra. Right? Let's see. A into B plus C. So it can be written as A into B plus A into C. This is one explanation. Similarly, A plus B into C plus D. So multiplying term by term means AC plus AD plus BC plus BD. That means if there is some this type of expression, so we can convert this expression to that form, like we did in normal algebra for normal algebraic operation. So same thing will be followed here. That's all. So these three are multivariable Boolean laws. So combinedly you are getting 8 plus 3, 15, right? 8 plus 3, how much? 11 plus 15 was it? Wow. Okay, so now we have to simplify some Boolean equation or expression with the help of these laws. Let's see. You know, থাকবে না লিখে নিয়েছিস? লিখে নিয়েছিস তো? First one, write down. Everybody should participate. Participate করবে মানে solve করবে। ফার্দার দিলে বুঝতে সুবিধা হবে। So first one, very simple. A plus solve the following Boolean expressions. the help of Boolean algebra. Number 1, a plus ab. Solve it. What you are getting? This is the given expression or equation. You have to simplify, solve, or basically simplify. It should be more appropriate if we use the term simplify, not solve. Or you can say no, solve. On a result of the solve it or simplify. What you are getting? A, right? How? So a plus ab is a, but how? A, so this is term 1, these are known as term, right? DER, term. So if you take common a from both the term, what you are getting? 1 plus b, and from the single variable laws you can get 1 plus a is 1. If 1 plus a becomes 1, so 1 plus b also becomes 1, because they are all variables. So we can write it is like this. So finally we are getting a, right? Similar, next solve it. A into a plus b, what you are getting? A into a plus b. What you are getting? A. All of you are getting A? Yes or no? Okay, fine. So again you are getting A. How? Term by term multiplication, right? A into A plus A into B. A into A is what? A. That means 8 times A's repetition is there. Then also you will get A. Now I want A plus AB. Now rest of the thing is same. Now number 3, A plus, now here prove what? Prove left hand side equal to right hand side. Answer is now given. Says A plus A bar B equal to A plus B. You have to prove it. This is left hand side, this is right hand side. Now you have to select a particular side at the left hand or right hand, depending upon your presence of mind and sixth sense. Then you have to apply the laws and you have to simplify, or you have to basically prove. Yes, left hand side we are considering applying all those laws, and after that we are getting right hand side, hence prove. What? What you are getting? Meaning is clear? You now have both sides, left hand side and right hand side, right? You have to consider either left hand side or right hand side, and you have to prove the other side. If you are considering right hand side, then right hand side becomes left hand side finally. You have that. Meaning is clear. What to do? That I am to take it. If we take right hand side, right, then it will be easy. a plus b is the right hand side. We are considering this one. A kotha is not that. Now in your left hand side there is a complementary term, sorry, variable, that is a bar, but in your right hand side it was missing, so you have to introduce that variable with the help of these laws without changing the meaning or value. So can we write a plus b in this way? We are simply multiplying 1 with b. That means it will not change the entire result. A plus b into 1 means what? A plus b, and 1 can be written in this way. In your Boolean laws, 1 means 1 plus a, or 1 means a plus a bar. So which one you have to consider now? The second one. Now a plus b into a plus a bar. Now term by term multiplication. So you will get a plus ab plus a bar b. So if you take common a from these two terms, you are getting 1 plus b plus a bar b. It is nothing but 1. So a plus a bar b, that is nothing but our left hand side. That is left hand side. Hence it is true. Right? Meaning is clear? কি করছে বুঝে গেছে তো? এইখানে একটু কি লাগবে, মগজ আসতে লাগবে। ফেলুদা ভেবে দেখেছিস? ফেলুদা সিরিজ, আরে ফেলুদা দেখেছিস? আর সানডে সাসপেন্সে গল্পগুলো তো ফেলুদা দেখেছি হয়, মগজ আসতে লাগবে। দেখ নেক্সট 4, problem 4. A into a bar b, a bar plus b equal to ab. Prove it. Got it. জলদি কর। টাইম লিমিটেড 4:30 হয়ে গেছে। That means you are getting ab. So if you consider the left hand side, then it will be more easy to solve. A into a bar plus b is a into a bar plus ab. A into a bar is 0. 0 plus ab, that is ab. Now problem 5. Problem 5. ab plus a bar c equal to a plus c into a bar plus b. এটা কর, এটা লাস্ট। এটা করলে আরেকটা কর, আরেকটা কর। a plus b more or less same জিনিস into a plus b bar equal to a.